So let's stick to the application layer for a second. So we have this protocol data and user data. Let's use a neat little visual to represent this combo. So this is PDU, or protocol data unit. So he's going to visually represent our protocol and user data for us as it travels. Let's move down to the presentation layer. So here we have our PDU now in the presentation layer. In the presentation layer, he's going to be compressed and his data will be re-encoded so he won't be as large. And remember how part of the PDU is protocol data, and that protocol data is HTTPS for secure HTTP. So let's see here what that secure portion means for our PDU. This HTTP is secured with TLS, or Transport Layer Security, which is a type of security protocol. This TLS protocol uses a symmetric key that was grabbed from the initial connection to the website as part of the web server request and response connection. So now our PDU is compressed and encrypted data. Now we've made our way down to the session layer. Here we're dealing with the session ID cookies. Here's an example of what a session ID cookie may look like to use. This is an example of a session ID cookie that lets Facebook's web server know which logged in user is talking to them. So now our PDU has obtained its session ID cookie, so when it reaches the server will know which user this request is coming from. Here we have two types of protocols. Let's start with TCP, or Transmission Control Protocol. This protocol requires a connection to be made between two devices. It's more reliable, but is also slower because the two devices need to acknowledge that they received the data. Some protocols that are part of the TCP protocol are HTTP, HTTPS, SSH, SMTP, FTP, and SFTP. On the other hand is a speedier but less reliable UDP, which doesn't require connection between the devices. UDP protocol data throws themselves at their destination with their best shot, and whatever gets there, gets there. Imagine throwing everything at the board and seeing what sticks. That's essentially what UDP is doing. Examples of protocols that use the UDP protocol are DNS, DHCP, SNMP, TFTP, and NTP. Remember our PDU with its cookie ID? Well, since it's using the HTTPS protocol, it's going to use the TCP protocol. As a TCP protocol, the transport layer is going to split PDU into different TCP segments. The segments will be labeled with sequence numbers. So when they reach the web server will know which order to accept the TCP segments. Welcome to the network layer. Here we're going to focus on the IP, or Internet Protocol information, that will be added to the PDU. This source IP here is the IP of our laptop that is sending PDU out. The destination IP is the IP of the web server we're sending our website data request PDU. So before we continue, we have to understand that there are private IPs and public IPs. Private IPs don't appear on the internet. They are only used in local networks or LANs. Private IPs are broken down into three classes. Class A uses the IPs 10.0.0.0 all the way through to 10.255.255.255. Class B, which can be used for medium-sized networks, uses IPs 172.16.0.0 all the way to 172.31.255.255. And finally, we have the most common one, and it's the one you probably have in your home network, which is Class C. Class C is for small networks and uses IPs 192.168.0.0 all the way through to 192.168.255.255. So going back to the destination IP, we can now see that this IP is not in our local 192.168.1.0 network, and it's also not a private IP at all. That means this is a public IP address. Because this IP is not in our network, we need to send our PDU to our default gateway, which is a router. How does our computer know that our default gateway's router IP is 192.168.1.1? That's because we either have our IP addressing set to DHCP and our network gives us an IP address and tells us basically, or we set it statically in our IP configuration settings in our laptop. But even with an IP address, we'll need to know the router's physical address to send our data to it. So how does a computer know our router's physical address? It knows the physical address through the user address resolution protocol, or ARP table on your computer. Here we can see the ARP table of my Mac laptop with the physical addresses redacted, which we'll learn more about in the next layer. So this ARP table is built using ARP requests that our laptop sends out to our network looking for other devices. Our laptop gets back the physical addresses and IP address of the device and keeps them in the ARP cache, which is eventually forgotten. These are known as dynamic ARP entries. If we want a permanent entry, we have to add a physical address and an IP address to the ARP table manually, which is also known as adding a static ARP entry. Here we're going to sit between the network and data link layers. With the new IP source and destination header added to the PDU, PDU has now become an IP packet. The ARP table is the reason why we're between the network and data link layer. The ARP table deals with IP addresses, which are part of the network layer, but it also connects the IP address to the physical address, which is part of the data link layer. So physical addresses are known as media access control addresses, or MAC addresses. The MAC address is like a device's social security number, right? So it shouldn't change, which means a hacker could pretend to be your router's MAC address and then make all of your data flow through them, meaning they could see all your data. That's why you see me redacting it all in the screenshots.